So we have seen that end systems, the devices which are participating in network communication. So it's either a client or a server. And so now let's look at now let us look at access networks. So the access network is actually a part of a network. It is actually that part of the network that connects the end system to the first router. What I mean to say is that suppose we have an end system E1 here, and this end system is actually a client, and it needs to send some message to some another end system E2, which is the receiver. And between E1 and E2 there are tons of, you could say, packet switches that lie between any number of them. So the access network would be the network that will connect the end system E1 to the first router, the nearest router. So that part of the network will be known as the access network. Why it is called the access network? Because this through this router we are able to access the internet. We are able to access the communication network. So this kind of network is known as the access network. Now the access network, if you look out, then one is a DSL and dial-up. DSL and dial-up are the you could say the was the first forms of internet medium access technologies that were available when commercially the internet was granted to the real customers in the market. It was open in the market. So commercial internet, DSL and dial-up were the traditional technologies. Dial-up used to offer a very excruciatingly slow speed of around 128 to 256 kb per second. Is that slow the internet was? It's not kilobytes per second, it's kilobits per second. So it's 128 to 256 kilobits per second, excruciatingly slow speed. It was being offered by dial-up, and the characteristic of dial-up was that it used the existing telephone connection. So companies, everyone had a telephone in their house. That existing telephone network was actually being used to access the internet. So what used to happen was that whenever if we are using internet in our houses, then we can't use that phone to actually use for calls. So if our line is busy and if we are accessing internet, that the regular calls that were once we able to make, we won't be able to make during that time. So all the calls would be dropped while you were accessing the internet. And if you're not accessing the internet, then you can use it as a regular telephone, and you can call your friends and family. So that was the disadvantage of the dial-up connection. Now we also had a DSL, which is a digital subscribers line. In digital subscribers line, this problem was resolved, and by using our DSLAM and the digital subscribers line multiplexer, access multiplexer, we'll study about them later in DSL and DSLAM. And the latest technology, it was FTTH, or the fiber to the home. So it used the optical fibers to deliver a very fast speed, high speed internet to the residents at home, and a dedicated optical fiber path was established from the company's office to the home. So this is the internet that is currently being used in the major part of the world right now. So we'll study the FTTH network right now. So typical FTTH network, internet access network. So I take an example of a company which is known as Reliance Jio. Reliance Jio is a very premium telecom company in India, and it offers an optical FTTH service. So in a typical Jio network, what happens is that we have some devices which actually we call it as routers in the common vernacular, but actually that term router is a bit wrong to say. So actually the device which we get using the Jio internet is rightly to be called as ONT. ONT is actually optical network terminator. ONT is optical network terminator. So an optical network terminator is what actually the company provides us with, and this optical network terminator is known as an optical network terminator because here the optical fibers they end. The optical fiber path which the optical network path, that the optical line cable. So this line is an optical network This is an optical network, this is an optical network. So beyond this, beyond the ONT, there is no optical cable. So it is rightly called as an optical network terminator. Now, a company, since the telecom company is Jio at hand, every company has a company's office in that particular city. That particular city has a one very big optical line terminator called as an OLT. This is a very shared medium. OLT is actually a shared medium. So from OLT, what happens is that OLT joins the traditional you could say non-optical network. This is a traditional non-optical network. So there are some packet switches, and this is all non-optical cables. From here, OLT is the beginning point of the optical cable network. So what happens? The traditional slow speed internet is now shipped into the company's office, and here they provide a very fast optical network technology to the residents by giving them access to by setting up an OLT. So this OLT provides this entire cable that you could say here is a shared medium, and this shared medium is very fast. It has a very fast shared medium, and high speed internet flows through this. And from this high speed line, many different other high speed optical cables stem out. So this is for a company's OLT. The high speed line cable starts from an OLT, and using an optical splitter it joins to different ONTs. Now these ONTs are which will be provided at our home. So this will be our home. This ONT is one home. You can show this is a home 1, this is an home 2, this is an home 3. So different homes are there. Every home has an ONT, and this is connected by an optical fiber. So this is an optical fiber cable, 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 and here the optical fiber cables they terminate. So it is known as an OLT. OLT is an optical line terminator. OLT is optical line terminator. Now from the OLT, regular non-optical internet has been present. So this is our company's office, which contains the regular high-speed spectrum that comes and carries and for delivery it uses the optical fibers cables for granting access to the internet. So that is exactly known as FTTH, or the fiber to the home. Now, before all these technologies, there was once a period of HFC. HFC is hybrid fiber coax. What happens that it is actually a combination of optical fiber and coaxial cable. Hybrid fiber coax. See, I talked about coaxial cable. That coaxial cable used in standard cable TV access, in the standard cable TV internet. And if you talk about hybrid fiber coax, it's actually a combination of, say, the word hybrid is there, of optical fiber cable and coaxial cable, and it is used to deliver high speed internet onto a cable TV access, on a cable TV internet access. So what happens? There was a technology that was very short lived in India, but it was much prominent in other countries. That was known as IPTV. And IPTV is Internet Protocol Television. So it uses the existing telephone connection to deliver internet into your home. And what happens that in IPTV, the entire cable, that existing the existing cable TV line that consists of a shared coaxial cable, that is joined with some optical fibers that terminate at our home, and through that optical fiber and through that combination of optical fiber and coaxial cable, we are able to get it fast internet access. Not as fast as the FTTH, because there is also an optical coaxial cable which is the bottleneck here, but yeah, much faster than the traditional dial-up and DSL technologies. So friends, let's look at an HFC technology, a hybrid fiber coaxial, or an HFC cable access network. See, when we talk about the HFC hybrid fiber coaxial cable access network, we're talking about the technology that exists, that is an add-on technology to the cable TV network. So we have some homes. In these homes, these homes have been attached with a coaxial cable to a fiber node. So a fiber node is a point that marks the termination of a fiber, that marks the termination of the optical fiber cable and the beginning of the coaxial cable. So the homes, they are well connected by a coaxial cable, but at the one end of the coaxial cable there is a fiber node, and a fiber node marks the path for the beginning of a optical fiber. So this lineage is an optical fiber. So on one hand we have a coaxial cable, on the other hand we have the optical fiber, and the fiber node is at the junction between these 2 points. So multiple fiber nodes, they have each of them have an optical fiber cable, and these optical fiber cables have been joined out as CMTS. So it is cable modem termination system. So this is a CMTS. So what is a CMTS? CMTS is a modem that is present at the company's office. So if this would be the company's office, this entire thing will be the company's office. At the company's office, this CMTS and the regular internet is been present. The regular traditional wired network internet is present. This is a very high spectrum, high speed internet that is present at the company's office, and it is been delivered from the company's office through the CMTS in form of optical fiber networks, each of which terminate at a fiber node, and this fiber node, they cater to particular homes. So this is for hundreds of homes we have one particular fiber node, and each of the homes has a coaxial cable attached to it. So this is a hybrid fiber coaxial cable access network where internet is also shipped alongside in the same channel of the coaxial cable along with the traditional wired cable TV. Next up, we have DSL internet access. DSL, as you know, stands for Digital Subscribers Line. Digital Subscribers Line. It's a very legacy internet access technology in which what happens is that the existing phone line connection is used to transfer the internet. Remember, it's not dial-up. In dial-up, what happens that dial-up is blocking, so that whenever we are trying to access the internet, the calls will all be dropped, and will not be able to use the line for regular communication. But in DSL, that is not the case. In DSL, what happens? The existing phone line is used, and this existing phone line has separate channels for voice and data, has separate voice and data channels. A separate channel for voice calls and a separate channel for data calls, for data needs. So in DSL, what happens is that we have a home. In our home, there is a phone and there is a PC. So in our home we have a phone and we also have a PC. The PC is connected with a modem. So modem, as you know, modem is known as modulator demodulator. So it will be used for converting signals. So what happens is that whenever the traditional telephone signals are being used, and this modem, it converts the digital signal into an analog signal that can be so that it can be transferred safely onto the phone line. So a computer will actually understand digital signals, but digital signals are not transported cannot be transported on a telephone line. So this modem, it converts these digital signals into analog signals, and these analog signals, they actually reach a splitter. So this triangle is actually a splitter. This is a splitter. So the splitter, it joins the telephone line at home with the internet line internet line stemming out from a PC. So the regular telephone line and the data line, internet line, they meet up at the splitter, and through the splitter, these two signals are merged together and multiplexed on a different on that existing telephone line. So the telephone line has separate channels. So it has an ordinary two-way telephone channel. So if I just write about channel, the existing telephone channel, I write existing telephone line. The existing telephone line, it has an ordinary an ordinary telephone channel, two-way telephone channel, it is two-way, for that will be used for calling. So it has a 0 to 4 kilohertz band frequency channel. This has one channel. Second, it has a high speed downstream or downloading channel. Downstream is when we are downloading stuff from the internet. Downstream channel. This is a very high speed downstream channel, and it has 50 kilohertz to 1 megahertz of frequency. The third thing that we have is a medium speed upstream channel. A medium speed upstream channel that has a frequency of about 4 kilohertz to 50 kilohertz. This is how we have a telephone line and three channels that are present in the telephone line. And this, so we have a separate channel for data signals and separate channel for voice signals, and each of these have been carried to the you could say company's office. So when we are requesting a page, the data moves from the company's office to our home PC, and when we are uploading something, the data moves from the home PC towards the existing internet. And this DSLAM has a DSL access multiplexer. See, because the DSLAM is used to actually break down and separate all the phone and data signals. So DSLAM is actually digital subscribers line access multiplexer. Digital subscribers line access multiplexer. This is DSLAM. This DSLAM is used to separate again the internet signals that goes from to the other internet network that is present, and the telephone signals that is now then routed into the telephone network, telephone companies. So this is what a main architecture of a DSL internet access network is there. Now what happens is that at a DSLAM, it is used to again separate out the telephone and the data signals. So the telephone signals have been separated and guided towards the existing telephone network, and the data signals have been routed to the internet. That's present. Okay, let us now look further and understand what a protocol is. So I have said in the past that the internet runs different protocols. As if you know that HTTP is also stands for Hypertext Transfer Protocol. So what actually this protocol stuff is, today we're going to be getting a deep dive down there. So a protocol, if I just look at the definition, what a protocol is, a protocol defines the format and order of messages that are exchanged between two or more communicating entities. This is one of the basic and could say the very simple definition of protocol we can say. So let us just try to understand and break it down with an example. Suppose that we are a student and we are being taught by a professor computer networks in a college. So what will happen is that whenever the computer network class is, the faculty arrives at the room, and you all greet him with good morning or good morning sir, good morning ma'am, you would say to him or her. And what happens is that after you just a formal greet, the lecture begins and you all actively engage in the content of the lecture. So if you just try to visualize, see, suppose you are the receiver and you could say receiver is a student, and here is a sender who is going to send all the content of the lecture, that will be a professor. So what will happen is that when the professor will arrive, you will see him, he will say good morning. The receiver will also greet him, they say good morning with a good morning, and after that such a with a formal, you could say, interaction, the he will tell you the syllabus, like you could say. He will deliver all the lecture parts, and if you have some doubt, you'll ask doubt 1D1, let us say, and again he'll proceed with some further lecture, and again you will finally say, okay, I have understood the lecture. You should say again, thank you sir, or ma'am, thank you message. This is what happens in a typical lecture in our college. So what we see is that here in this particular scenario, we have particular way in which the session is conducted. First of all, there is a proper mutual greet between the sender and the receiver, and then all the data is transferred, or you could say the main content is being delivered to you, and if you have some queries, there is an interruption, and you can properly answer them, and then your doubts are also addressed, and then the another part of the lecture is proceeded, and finally there is a conclusion part when you say thank you and the connection is ended, and that is the professor moves back to his cubicle. Okay, so this is a typical. So if you could say that there is a particular typical format that has been followed in every lecture. So protocol also is actually a way of is a formal document in which properly it is defined that how and in which format will two communicating entities, which format they'll use to establish a connection and send messages between one another. That is a protocol is. So if you just look at it in terms of a simple client server protocol, you have a PC, this is another PC, they want to communicate. One may be the client, other might be the server, and the client, it first tries to contact with the server, so it sends a request, and if that request properly acknowledged, then the connection is established, and now the communication begins. It can send a message M1, can get a reply R1, then another message M2 can be sent, another reply R2 is got, back is given, and then finally the connection terminates. Connection ended. Okay, so the manner in which this communication will be established and the messages will be sent, and the format and the content of the message, will be defined in a protocol. And that protocol, if we talk about the intent for now, it is HTTP, that is known as Hypertext Transfer Protocol. So we have different protocols for different services. We have Hypertext Transfer Protocol for communication across the world internet, and we for sending different files, and we have an SMTP protocol, SMTP, Simple Mail Transfer Protocol, Simple Mail Transfer Protocol for sending and receiving emails. Moreover, we have emails. Moreover, we have an FTP protocol, that is the File Transfer Protocol, that is mainly used for sending and receiving files, static files on the internet. Similarly, we have a connection establishment protocol, that is one is a TCP and there is a UDP. So we'll be understanding the difference between the TCP and UDP in the subsequent lectures. TCP is the transmission control protocol, and UDP is the user datagram protocol. We'll be looking at all of these protocols in the future lectures. So yeah, now what happens is that to send these messages in a prescribed format, we need some kind of an internet API. We need some kind of a you could say the guidelines have been present in an English language. See, our protocol is written in English like language, but the computers, they don't understand English. So what happens, since the computers, they only understand language that is related to a particular code, say might be Python, might be Scala, might be Java or something else, they implement a protocol in their own particular native language. In each language actually implements a protocol. So how does it implement a protocol? It provides us with an API, that is an programming interface, an application programming interface. Each programming language provides us with an application programming interface on which the data, on which every protocol has been implemented. So application programming interface is the programming construct that is written, that is app programming specific, and that is actually being used by the end system. That serves as an machine instruction for different devices, clients and servers, then different systems and different end systems, and that programming instruction has been understood by these computing systems, and hence a protocol has been implemented, and the data can be shared between different devices. So if we just talk about an application programming interface, see, application programming interface also is dependent upon the type of application that you are building. Certain applications provide every programming language has different use cases for different applications that can be written on the internet, and some interfaces are well implemented in one particular, some protocols are well implemented in one particular application language, and others are implemented in a different application, but others are implemented better in a different programming language. So yeah, when we talk about an application programming interface, it has been written at the application level, that is it has been written and executed at the client and the server level, and in the computers of the client and the server, not in the underlying and not implemented in the underlying infrastructure. Only the computers that are running at the client and server, they conform to the application programming interface, and they communicate through each other using something which is known as a socket. Okay, I will be talking about sockets greatly later, but socket is actually a kind of a, you could say, a simple door, a logical door. It serves as a logical door, a door through which information enters or leaves an end system, through which an information, like a door is in our house as a particular door for that serves as an input of medium of input and output. The door in a socket in an end system does the same thing. It serves as a logical door through which information enters or leaves the end system. Okay. Now to interact with the socket, what we have is our to interact with the socket, there is again an API or a programming interface that is known as the socket interface. Now different programming languages, they provide different APIs for interaction with the socket. And so what is a socket interface? A socket interface is actually you could say a specific, it is a manner in which we specify how how an end system will ask the infrastructure, will ask the existing internet infrastructure to deliver data to a particular destination on another end system. So by using the socket interface, we can control the socket, and we can if we control the socket, we can control how an end system how we can control the underlying infrastructure, and we can tell the particular end system that how we want to convey a particular packet to a specific destination on an end system. So that will be provided by the socket interface. So it's actually a programming construct. Using the socket interface, it consists of some programming code that will be used to configure a socket. Okay. Like, so if you just want to so if you are trying to say like how we can configure a socket, or how it happens, let me just understand it with a simple analogy. See, suppose Alice wants to send a message to Bob. So what happens is that Alice, it uses the existing API. Now API is the existing internet infrastructure, or for her it will be the existing internet infrastructure that will be used. So actually Alice just can't write the letter and just leave it there and hope that Bob will reach the letter will reach the Bob. No, Alice can't hope for that for sure. But there are certain steps that Alice has to perform in order to even think that the information that the letter will be delivered to Bob. So what will happen? Alice will try to first write the letter, that is write the content in the letter, put Bob's entire address on the letter. Then Alice has to put down the stamp, and then it has to put the letter on the letter box. Inside of the letter box, she has to put the letter inside the letter box. After then she has been done with all these processes, then only she can hope that the letter will reach Bob. So what happens is some steps she needs to follow. So these steps are actually the protocol that has to be followed, and in order to implement all these steps, that APIs will be used to actually and convey the information, like which part of the letter will have the content, which part of the letter will have the address, which part of the letter will have a stamp. So all these values and all the data that will be supplied through an API. And when all these data have been passed, then it can ask the socket. The socket is actually the letterbox on here. This is acting like a socket, because here, if Alice's job is just to carry the letter with all these different attributes and all the contents and all the information attached to the letterbox or to the socket. And once she has then attached, when she has successfully made the letter into the letterbox, she can hope for a reliable delivery. So what if we just try to build an analogy with the socket? We could say that by using the different that one must have a knowledge about a particular protocol, and then one must have a knowledge about all the APIs, and after all these knowledge, they can safely write the particular content of the message and what they want to send, and put the letter into the letterbox. That is try to configure the appropriate socket, and once we have interacted with the socket and passed on a letter through the socket, we can hope for a reliable delivery. Okay. Now one thing is that in this step, in this Alice and Bob analogy, we never had an opportunity for an Alice to first make a connection to Bob. That was missing. So one more step that we have to do before initiating a communication is handshaking. What is handshaking? Handshaking is establishing a connection. Establishing a connection between the parties, between the communicating entities. Establishing the first connection the first connection between two communicating entities. This was not in part of an analogy, but this is something that will also this is something that one also needs to do before sending and receiving messages. That is handshaking. That is establishing the first communication between the communication entities. See, we have done this in protocol. See, whenever in our faculty and in our professor and our student example, this good morning and good morning, this was our initial handshaking. Here first our connection was established, and then the lecture part, the main content of the lecture was delivered. So here also, if I talk about in a client and server architecture, the client first sends a connection establishment request, and then a connection is successfully established by the client or by the server to the client. So first of all, we have to establish a connection. Then we have to understand how different APIs work, and then after the configuration of the APIs, we have to configure the socket using the socket interface, and then safely send a message to the parties. Okay. Hello friends, in this video we'll be looking at the history of the computer networks. So if you just look that the computer networks, they were present not in the 1960s. They came in the 1960s to the 1970s. So what happened, the situation in 1960s was that the computers, they were mainly standalone. They were not connected with the other computers. Computers from different manufacturers couldn't communicate. So a company which is known as ARPA, Advanced Research Projects Agency, they thought that they need the computers to communicate with each other. So they thought of forming a network, which they named as the ARPA net. So in 1967, what happened? The members at this ARPA, they gathered together at a conference which is known as ACM, or the Association of Computing Machinery. There they discussed the ideas of this ARPANET. They thought that each computer, they will be connecting each of the computer to a specialized computer which will be called as the IMP. IMP is the short for Interface Message Processor. So what will happen is that these are those few of the computers from different manufacturers like IBM, HP and Intel. They have been connected to a specialized computer which is IMP. In each of these computers, they run a software which is known as NCP. NCP stands for Network Control Protocol. So what happens? There are computers of different manufacturers. Each will be connected to a specialized computer which is known as an IMP. And we have two of such networks. So we have one IMP here and another IMP2 here. Now these IMPs, they will be communicating with each other. And this is so it's kind of a master-slave architecture where there's a master node which is IMP. This is a specialized node, and this specialized node is having the powers to communicate. It has the super power to communicate, and it can communicate to the other IMP, which is in turn attached to all the slave nodes of the architecture. So of different manufacturers. So such an idea of network, it became successful in 1969 when 4 different networks were successfully connected, and ARPANET became the first successful computer network in 1969. So if you want to know the names of those 4 computer networks, I have taught this previously. See, I said that 4 different nodes, 4 different computers, one at the University of Berkeley, another at the University of Utah, another at the University of California at Los Angeles, and again the 4th one being the at the Stanford Research Institute. These 4 computers, they were communicated, and ARPANET became a reality in 1969. What happened subsequently was that there were problems. Some problems that these ARPANET networks faced was that they had a centralized failure of point that was IMP, which had to handle all the communication across nodes. Second was that the data that it was being sent across was prone to corruption due to bad weather. Moreover, the computers, since they were of different manufacturers, they had different processing power, so they could transfer data at varying speeds, at unequal speeds. which could also lead to congestion in the network. So to address these problems, what happened? Two different employees at the ARPANET, two different research interns at the research personnel at the ARPANET, Surf and Bob Khan in 1972, they addressed these issues and they developed a device called a gateway. With this gateway, they could overcome the problems. Which problem they could overcome? They could overcome the diverse programming interfaces problem, because see, the computers, they were of different companies, different manufacturers, so there are different application interfaces, different programming interfaces, and which pertinent they use different programming interfaces. So to establish a communication between diverse programming interfaces, it was a big problem that was overcome by Surf and Bob Khan in 1972 by developing a device which is known as the gateway. Okay. So with the advent of the gateway, some modifications in NCP were to be made. So the gateway technology was added to the NCP software, and for the first time, the end-to-end delivery of data was now made possible. The responsibility of error correction. I said now that the errors were introduced due to bad weather. So the responsibility of error correction was handed over to the host machine instead of the IMP. So now not the IMP, but each of the individual hosts that runs NCP will be responsible for checking the errors and all. And in 1973, the Surf and Bob Khan they actually published their paper on the TCP model, or the transmission control protocol, wherein they addressed some concepts like packet encapsulation. They underlined what a datagram actually is, and the functions of the gateway were properly mentioned there. So with all these happenings, what happened? The different changes they became introduced into the NCP software, and with such breakthroughs, the DCA, the Defense Communication Agency, it became interested in the ARPANET. Finally, in 1977, it is 4 years after the publication of paper on TCP, 3 different networks, the ARPANET, packet radio and packet satellite networks. In October 1977, 3 different types of networks, ARPANET, packet radio and packet satellite networks, were successfully interconnected. And now TCP was now further split into 2 parts. First was the TCP itself, the transmission control protocol, and the second part being the IP, or the internet protocol, each having different responsibilities. TCP would be responsible for packet segmentation and packet reassembly. See what I mean by packet segmentation. See, whenever the information is transferred, then it is transferred in packets. So these packets are actually, the information is broken down into packets. These packets have been now need to be segmented, and each packet they need reach the destination, and at the destination point, each of the packets are reassembled together so that information is reliably reorganized again. So the responsibility for packet segmentation, packet reassembly, and if errors have been introduced in the packet, so error correction responsibilities were given to the TCP, and the IP would only be responsible for routing these packets across different routers. So datagram routing would be the responsibility of the IP, or the internet protocol. Now, it was only in 1981 that an open source version of TCP was released. See, when all these technologies they came, TCP was also split. What happened? And in 1977, 3 different types of networks were successfully interconnected. These are major breakthroughs. So the developer the people, the research people, the scientists, they were very confident about their technology. So they wanted now to open the technology for the developers to build applications on the TCP IP model. So it was in 1981 when, under the DARPA contract, the Unix operating system, it added the module for the TCP IP model. As you know, Unix is an open source operating system. So the open source community now could engage with the TCP IP model, and as a result, after the TCP/IP model. After such an introduction of TCP/IP to the developers community in open source, different networks they began to be founded. So the MILNet, the military founded its own network, which was known as the MILNet. That was simply ARPANET with enhancements for the military use. CSNet was also formed. It was sponsored by the NSF itself, the National Science Foundation, and NSFNet, it actually became popular. So all these things happened. One important thing to note was that the original ARPANET protocols were now abolished in 1983, and the TCP/IP, the current TCP/IP protocol, they became the new ARPANET. They were the official ARPANET protocol. So CSNet was founded. CSNet was a network of the university computers in the United States. Was founded by the NSFNet. As NSFNet, in NSFNet also in 1991, NSFNet also founded a network of 5 supercomputers across the United States in 1986. So 1996, all 5 supercomputers in the United States were connected by a network that was known as an NSFNet, and people were granted access to this internet technology. And as you know, as the internet became caught the public eye, it exploded. Many different devices, they were now connected into the internet, and now NSFNet now became incapable to handle such an ever-increasing network traffic. So NSFNet realized that it realized now that the traffic volume is very high and it could not cope up with such huge traffic. So it shifted back its attention to being just a research network, and handed the entire network infrastructure to a network which will be called as the ANSNet, which was now funded by companies like IBM, Merit, and MCI in 1991. And this ANSNet slowly became the modern internet.